So this week, we're going to be taking a look at 2.2. As I said, we'll split that into 3 days. Parts 1 and 2, you won't really need a calculator for. When we get to part 3 on Wednesday, you'll need a calculator for that one. Okay, so I would suggest if you have one, you can bring it. If not, you can borrow one of mine. All right, so let's start out just by looking at that diagram. So the trig that we're going to be looking at this week is based on using a circle. Okay? And it's what we call a unit circle. What makes this a unit circle is the size of it. A unit circle is a circle with a radius of 1. So it's a radius of 1. As we go around the circle, okay, counterclockwise, we have different angles that I've marked. So if you go right, we've got 0, up is 90, left is 180, and down is 270. And remember, the radius of this circle is 1. So it's 1 unit in every direction to get to all of those points. 1 unit right, 1 unit up to get to 90, 1 unit left to get to 180, 1 unit down to get to 270. And you can think of that in the middle, that's kind of like the origin. That would be the coordinate 0, 0. So, the goal with unit circle trig is to figure out a coordinate. That's the whole goal. So you can give me any angle. Usually we're going to work with angles that are multiples of 30 and 45. Okay, those are the easiest ones to do on here. So that's what we're going to do. So if you give me an angle that's a multiple of 30 or 45, I can put it somewhere on that circle, and then I can figure out the coordinate for it. And that's the whole key, okay? Figuring out a coordinate. And then you take that coordinate and you do something with it. Okay? And I'll show you what you do with it. So let's start just by looking and seeing if we can figure out the coordinates for the 4 points that I have up there. Okay, the 0, 90, 180, and 270. Remember, it's 1 unit in each direction to get to those points, okay, because they're on the edge of the circle, and the circle has a radius of 1. So let's start with 0. To get to 0, all you have to do is move right 1 unit. You don't move up or down. Anyone think they could tell me what the coordinate would be if you moved from the origin right 1 unit to where the 0 degree mark is? Yeah, Jason?
1, 0.
Yeah, exactly. It's 1, 0. That's the coordinate for 0 degrees, and that never changes. It's always the coordinate. Okay, how about for 90? Anyone else have an idea what 90 might be? Yes, is it Allie?
Yeah.
Yep.
Would it be 0, 1?
That's 0, 1. So in that case, the x is 0 and the y value is 1. It is important to understand which one the x is and which one the y is. So x is first, y is second. All right. How about the coordinate for 180 degrees? Yeah, Brian?
-1, 0.
So we get -1, 0. So now the x is -1 and the y is 0. And how about for 270? Anyone think? Yeah, Ethan?
0, -1.
Good, 0, -1. These are the only coordinates that have zeros in them. Because if a coordinate has a 0 in it, it lands right on an axis. And we've done every point that lands on an axis. Okay, so any questions on those 4 coordinates? For today, those are the only coordinates that you would have to figure out. Those are the only angles that you would have to figure out the coordinate for. So when you get to a problem like this, okay, we're not doing this yet, but it says find the 6 trig functions of 90 degrees. Step 1 is what is the coordinate for 90 degrees? You write that down. Once you write down the coordinate, you have an x value and you have a y value. These 6 formulas use the x and the y value in some way to get the answer. And I'm going to show you how you do it. Questions on those points? All right. Now, there are two directions that we can rotate on when we go in a circular pattern. You can go clockwise or you can go counterclockwise. If you go in a counterclockwise direction, you'd have a positive angle, and if you go in a clockwise direction, it would be negative. All right, so just to demonstrate again what it looks like if you have a positive angle versus a negative angle, I'll bring up a little program where I can draw different angles. So as I rotate counterclockwise, you can see that it gives me a positive angle. The top number is degrees. Anybody remember what the bottom number is called? The other way that we measure angles? Ellie?
Radians?
Radians, yep, so that's radians. We might still do some converting between degrees and radians this week. So we'll kind of refresh what that is if you don't remember. All right, so if you had something like that, the coordinate for that point would be, well, that's 90 degrees, so that's 0, 1. That's the coordinate. I know this grid looks a little different, but pretend that it's 1 unit in every direction. So that's the coordinate for 90 degrees, 0, 1. Now if I did this, how does the location of where that red circle is now compare to where it was for 90 degrees? That's 450. Yep.
It doesn't?
What do you mean it doesn't?
It doesn't change. It would still be 0, 1.
It's still 0, 1. So if you have a 450 degree angle, the coordinate for that is still 0, 1. If you have a 810 degree angle, it's 0, 1. If you have 1170, that's all 0, 1. The problem is, if you said something like that to me, and said, what's the coordinate for 2,250 degrees? Off the top of my head, I probably wouldn't know that. Because you've gone around so many extra times, that's hard for me to visualize where it is. So, what number do you think I could subtract from 2,250? And I might have to do it several times to make it smaller. And as long as you subtract this number, it always puts you back at the same spot. Jason?
360.
Yep, you can subtract 360. And anytime you subtract 360, all you're doing is making it one revolution smaller, but you're bringing it back to the same spot. The goal is to make this number smaller. Okay, that's still too big, too big, too big. We want to keep going until we finally get an angle about like that. And now I'd say, oh, 90 degrees, that's an easy one to work with. The coordinate is 0, 1. But it's the same as that 2,200 and whatever it was. Right? So you can subtract 360, but you don't want to subtract it too many times. Because if you keep subtracting 360 too many times, what's going to happen to your angle? It's going to go negative. Well, you don't want it to go negative either. Right? So you don't want to have an angle like this, and you don't want to have an angle that's too big. You always want to try to get an angle between 0 and 360. Now, if you accidentally subtracted 360 too many times and you went negative, how do you think you could fix it?
Add 360.
You could just add 360. All right, so this adding and subtracting 360, you can do that as many times as you need to. So if you need to reduce an angle and make it smaller, you can subtract 360 as many times as you need to. Stop when you're between 0 and 360. Don't keep subtracting. And same idea, if you have a negative angle, if you want to take a negative angle and turn it into a positive angle, you can add 360 as many times as you need to. But stop once you're between 0 and 360. Don't keep adding it, then it's going to get too big. And this is where the converting between radians and degrees might come in. If you have an angle that's in radians it's probably going to be easier for you to do the arithmetic in degrees. You don't have to. You can do it in radians, but it's probably easier in degrees. Does anybody remember what 360 degrees is equal to in radians? Ethan? It's equal to 2 pi. So think about that. 2 pi is the same as 360 degrees. If you're going to do a problem like this and you really want to do it in radians, then you wouldn't be adding or subtracting 360. You'd be adding or subtracting 2 pi. That's a lot more complicated to think about. So I think 360, do it in degrees, that's going to be the way to go. All right, so when we get a problem that's in radians, I'll remind you how to change it to degrees. Okay. Any questions on those 2 steps? All right, so once you've made your angle between 0 and 360, so it's a little easier to think about, and you've figured out the coordinate, whether it's 1, 0, 0, 1, these are the only 4 you have to figure out today. Then you're going to take that coordinate and you're going to plug it into a formula. Now remember, coordinate has 2 parts to it. It's got an x value, and it's got a y value. The x value is first, the y value is second. And I'm going to give you 6 definitions. Okay, and these definitions are going to be the definitions of the 6 functions that we study in trig. Okay, the 6 main functions. And I think this is the first time we've seen them in this class. Does anybody know the name of one of the functions you study in trig? Ethan?
Sine.
Sine, yep. Sine function, that's one. Yep.
Yeah.
Tangent, that's another one, abbreviated TAN. Anybody know another one? Sine, tangent. Yep.
Cosine.
And cosine. Those are the three basic ones. Sine, cosine, and tangent. And the abbreviations for them all use 3 letters. Sine is abbreviated SIN. You still say sine. Cosine, COS. Tangent, TAN. I've heard people say tan, and you can say tan, but nobody says sin. They say sine. I don't know. So you got sine, cosine, tangent. Right, and here's the formula for each one. So this represents an angle. If in the problem they give you an angle, the angle is not really what you want. You need the coordinate. That's what you have to find. So if they give you an angle, like say 90 right here, your first job is to figure out what's the coordinate for 90. So you'll have an x and you'll have a y value. And then the question might specifically say, what is the sine of 90? So you'd say, all right, I've got the coordinate. He wants to know the sine. That means I need the y value of the coordinate. That's all you need to use for sine, the y value. If I ask you a question about the cosine of an angle, step 1, you have to find the coordinate. Step 2, cosine means I want you to specifically give me the x value of the coordinate. These 2 trig functions only use either the y or the x. Tangent uses both. So if I ask you a question about tangent, step 1, find the coordinate that represents an angle. Step 2, take the y value and divide by the x value. And that's how you find the tangent. So these are the 3 main trig functions we use. Now there's 3 others. And the first one is cosecant. And I wrote it across from sine for a certain reason. There's a pattern here. when I wrote sine, I didn't write it as a fraction. But you can make anything a fraction by putting it over what number? 1. You could always put it over 1. I'm just going to put it temporarily. I'm going to erase that. But y over 1 is the same thing. Anybody see the connection between the formula for sine and the formula for cosecant? Yeah?
It's the opposite, if the reciprocal.
Yeah, it's the reciprocal. And that's how all of these on the right are going to work. If you take the one that's on the left and you flip it, you get a different one, and that's the one on the right. So the names of the other two are secant and cotangent. And anyone have a guess what the formula for secant is going to be? Yeah, Dylan?
1 over x.
Yeah, it's going to be 1 over x. And how about the formula for cotangent? Any guess on that one? Yep,
X over y.
that's going to be x over y. So there really is not 6 different formulas to memorize. If you know sine is y, cosine is x, and tangent is y over x, all you have to remember is take everything I said, flip, flip, flip. You flip them all, and you get the other 3. Okay, questions on those formulas? All right. So we've talked about 4 angles so far. By the end of the week, we're going to talk about a lot more than 4. Okay, we're going to talk about all angles that are multiples of 30 and 45. But the first 4 angles that we talked about, 0, 90, 180, 270, those are called quadrantal angles. The reason why they're called quadrantal angles, because they're angles that are right on an axis. And for today, those are the only angles that I would ask you to find a coordinate for. And try to remember what these coordinates look like. They all have zeros in them, and they all have a 1 or a negative 1. They're the 4 easiest coordinates we're going to work with all week. Those are called quadrantal angles. All right, so I've already said this verbally a couple times, but how do you actually do unit circle trig? What do you got to do? So step 1, when they give you a problem, is locate a coordinate. You have to figure out a coordinate. Now, if you look at what I wrote in parentheses at the end, it says sometimes you'll be given the point. If it's a 0, 90, 180, or 270, I would expect you to be able to figure out that point right now. Okay, because we did the diagram and you can look back and see what it is. But other than that, I haven't explained to you how to figure out any other points yet. So if I want to do a problem that involves an angle that's not a 0, 90, 180, or 270, you don't know how to find the point. I have to give it to you for today. Okay, so for today, I would give it to you. All right, so step 1, locate the point. Once you figure out the coordinate, plug it into a formula. Okay, what formula? Well, whatever one they want you to do. They'll tell you in the problem. Find the cosine, find the tangent, find the secant, right? They'll tell you which one they want you to do. But it's all dependent on you being able to figure out the coordinate. If you can't figure out the x and the y value from the coordinate, you can't do unit circle trig. Doesn't work. Now, on a test, the way I would probably set it up, or the way I will set it up, is I'll ask you for one trig function per problem. Like question 1 might be find the sine, and I'll give you something. Question 2, find the cosine. The way we're going to practice it right now is we'll do all 6. So we'll do the sine, the cosine, the tangent, the cosecant, the secant, and the cotangent. All right, so here's the point. I'm giving you this coordinate. Does that look like the coordinate for 0, 90, 180, or 270? Does it look like any of them? No, it's not. Okay. It's a coordinate for some other angle. What angle is it? You don't have to know. Don't worry about what angle it is. The angle is not important. What's important is you have an x value and you have a y value that represents somewhere on the circle. All you need to know is the x and the y. Okay, so that point, it represents some angle on the circle. Maybe by tomorrow or Wednesday, you'll know what the angle is, and you'll know how to figure out that coordinate yourself. But for today, I'm giving you that coordinate. And I want you to find the 6 trig functions of the angle that's represented by this location. That's what I want to find. 6 trig functions represented by the angle at that coordinate. And again, through the whole problem, you're never going to know what the angle is. And sometimes that confuses people. Well, the goal here is not to figure out what the angle is. The goal is to figure out what the sine of the angle is, what the cosecant of the angle is, what the cosine of the angle is, not the angle itself. And sometimes the way I describe it is it's kind of like describing you versus what your name is. So that's different things. I don't need to know your name to describe you. I can look at you and say what color shirt you're wearing, how tall you are. I can describe a bunch of things about you without even knowing your name. And that's basically what you're doing here. You're describing some things about the angle without ever knowing its size or its name. And that's fine. We can do that. All right, so let's start with that coordinate. -1/2 root 3 over 2. All right, so Devin, what's my formula for sine?
It's like there equals y.
Okay, so it's y, and what's my y value here?
It's the 3 over 2.
Root 3 over 2, yep. So the sine of the angle represented by this coordinate is root 3 over 2. Question on that?
Do you have tissues?
Paper towel?
That works, man.
All right, how about cosine?
Yeah.
Tyler, what's my formula for cosine?
Angle is equal to x.
What is it?
Angle equals x.
Yeah, so the formula I'm looking for here is the x value. What's the x value in my coordinate?
-1.
-1/2. Right. Any questions on those first two? Those are probably the easiest two to do because you don't have to do any fractions, you don't have to flip anything. It's just one of them is the y value, one of them is the x value. Done. All right, let's look at tangent. Bridie, what's my formula for tangent?
Y over x.
Yep, y over x.
Dude, I have way too
All right.
many videos about
So we were going through this one and we're figuring out our trig functions, and I had just asked Variety, what was tangent? And she said y over x.
Okay, that works.
So
That's gonna be-
when you're doing y over x, okay, that's one where you have to divide. Okay. Variety, what's my y value here?
Dylan.
The 3 squared over 2.
Can you say it again?
3 squared over 2.
So
Oh,
3.
square root of 3 over 2.
Okay, yeah. So square root of 3 over 2. And what I'm going to do this one off to the side. And I'll put the answer next to tangent. Square root of 3 over 2. And then my x value, negative a half. Okay, when you divide two fractions that have the same denominators like this, the denominators cancel out. The reason why they cancel is because normally you keep the top the same, you change to multiplication, and you flip what's in the bottom. Keep, change, flip. Might have heard that before. Well, if you take what's in the bottom and flip it, it would go next to it, and the 2 would be in the top. So you'd have a 2 in the top and a 2 in the bottom. So the denominators are going to cancel out. All you're left with now is the square root of 3 divided by negative 1. Let me put it just like that. All right, it's a negative square root of 3. Any questions on the tangent? All right. Now, at this point, you don't even have to go back to the coordinate. If you've done these 3, all you have to do is look at these 3 answers. What did we say earlier you do with the one on the left to get the one on the right? Just take each one of them and do what?
Inverse.
Yeah, just flip them. Just take each one of them and flip them. So let's just look at that and flip it. How about, Haley, if I take the value for sine and flip it, what do I get?
Would be 2 over
2 over the square root of 3. So what she did is correct. She flipped it. But when she flipped it, what happened that we generally don't like to have happen?
Square root.
Yeah, we got that square root in the bottom. So when we get a square root in the bottom, we have to fix it. And this is something I think we talked about last week. Does anyone remember what we have to multiply by to fix a square root in the bottom? Yes.
Square root of 3.
Square root of 3 over?
Square root of 3.
Square root of 3, yep. And now you multiply straight across. So in the top, 2 square root of 3. And in the bottom, the square root of 3 times the square root of 3. Well, that's the square root of 9, which is how much? 3. So that's the final answer for the cosecant. Doesn't always happen, but anytime you have a square root on the top, on the left, well, when you do the one on the right, it's going to go to the bottom and you have to fix it. All right, how about my secant? Anyone think they can tell me what that one would be? Yep, Allie?
That'd be negative 2.
-2. You're going to flip that. So when you flip something that's negative, it stays negative. That doesn't change. You just take the top and the bottom and switch places. You're not wrong if you put -2 over 1. You can. But you could just put -2. All right, and the tangent, cotangent. So Tyler, how can I make tangent a fraction? Because right now it's not a fraction. The tangent.
By flipping it, so it's a 1 over square root of 3.
Right, so when you flip it, if you're not sure what to flip because there's nothing in the bottom, pretend like there's an invisible 1 there. When you flip it, it's going to be -1 over the square root of 3. And what's wrong with that, Tyler?
There's a negative.
Negative is okay. We don't mind that. This has a problem that we had in the one when we did cosecant. Same problem.
It's because the square root is on the bottom.
Yep, we got that square root in the bottom. And Caitlin, can you remind us how we would fix that?
You would multiply by the square root of 3 over the square root of 3.
Square root of 3 over square root of 3. Good. All right, and Jade, when I multiply, can you tell me what I get in the top?
You would just get square root of 3 over 1.
Um,
Or
negative.
Yeah, negative square root of 3. So we get that. And Ryan in the bottom, what do we get?
Just 1. Or is it negative 1?
Well, what are the two things you're multiplying together?
Oh, square root of 3 and negative 1.
You're multiplying square root of 3 and you're going straight across.
Oh, square root of 3.
Square root of 3. So what's the square root of 3 times the square root of 3?
3 squared.
Well, the square root of 3 squared, which would be how much?
3.
3. So we get 3.
Yeah.
So that's our cotangent.
That's a easy one.
Okay, so that one would be 6 different questions on a test, one for each trig function. Okay, any questions on those? All right, so let's see this one. So this time they're giving you the coordinate root 2 over 2, comma, root 2 over 2. Does that look like the coordinate for 0, 90, 180, or 270?
No.
Nope. It's because it's not. We'll talk about that angle tomorrow, but anyone have a guess what angle that would be the coordinate for?
360.
So it's where you go the same amount right and the same amount up. The x value and the y value are exactly the same. So you're going over a certain amount and up a certain amount, and they're exactly the same amount. Yeah?
45.
Yep, that's the coordinate for a 45-degree angle. Tomorrow, I'll show you how to figure that out. You don't have to know it for today, because I'm giving it to you right there. So there's your x and your y. Okay, so let's go through all 6. Justice, what would my sine be here?
I'm not sure.
Okay, what's the formula for sine? Well, it looks like you got your Chromebook out, so why don't you go on Google and type in unit circle trig formula for sine. See what it says.
Hypotenuse, or opposite divided by hypotenuse.
Sine is opposite over hypotenuse when we're doing right triangle trig, but this is unit circle trig. That's what I told you when you typed in unit circle trig?
Yeah.
Huh, okay. Anyone remind him what's the formula for sine? Yeah, Katie?
Equals y.
It equals, what is it?
Y.
Y, yes. Good. And what's my y value in this case? So what part of the coordinate is my y value?
Square root of 2 over 2.
Yep, and which one is it? Which part of the coordinate?
The numerator.
This part, or the first part, or the second part?
The second part.
The second part, right? In this case, if you switch the x and the y value, you'd get lucky because they are the same, but you should know it's the second part. Okay, it's the y value. 2 over 2. All right. Noah, how about my cosine?
Square root of 2 over 2.
Yep, that's my x value. So again, if you switched it with the y, in this case, you get lucky. But you shouldn't switch it. And Jason, what's my tangent? What's my formula for tangent?
I think that's the one thing I didn't have written down.
Right, someone remind him, what's the formula for that, Gina?
1 over x.
Y over x, yep. So the formula is y over x. And what do you get in this case if you divide y by x?
You get square root of 2 over 2 divided by square root of 2 over 2.
Mm-hmm. And what does that come out to?
Let's see. Square root of 2.
Well, how do y and x compare to each other? You just said what y was and you said what x was. How do those two values compare?
Not sure.
How do they compare? Yep, they're the same. So you're dividing y by x and they're the same. So what do you get when you divide two things that are the same?
The same answer.
Well, take 3 divided by 3. Just take two other
Oh,
things.
1.
Yeah, you get 1. Doesn't matter what two things you divide. If they're the same, you always get 1. So that's my tangent.
That makes sense.
All right. How about my cosecant? Let's see. How about Ariana? What's my? You don't have to give me the final answer. Can you just tell me the first step to find it?
This angle equals 1 over y.
Okay. And so I've got y right here, and you said 1 over y, so it basically just means to take this and do what with it? Flip it. And what do you get when you flip that?
2 over the square root of 2.
Good. So that's the first step. And John, how do I fix that so I don't have the square root in the bottom?
They do the reciprocal of it.
So we did the reciprocal. We already flipped it.
Right, you have to get the square root at the bottom.
Yeah. So we want to multiply by something.
Can you just multiply by the square root, like square root of 2?
Yep. Square root multiply by square root of 2 in the top. And what do you have to multiply by in the bottom?
Same thing.
Same thing. Yep. So we're going to multiply top and bottom by that. And Emma, when I do that, what do I get in the top?
2 times the square root of 2.
And in the bottom?
2.
2. So I have a 2 in the top, a 2 in the bottom. I can cancel those out. And I get square root of 2. Eventually, by the end of the week, you'll probably just have it memorized. If you flip root 2 over 2, you get root 2. And you don't have to. You can figure it out every time, but eventually it comes up a lot. How about the secant? That one should be pretty quick, yep.
Square root of 2.
Right, it's the same thing, because the sine and the cosine are the same. So you're just flipping the same thing again. Square root of 2. And how about my cotangent? Natalie, can you tell me what my cotangent is? Yeah, it would be 1, right? Because once you have the tangent, you just take that, you flip it, there's your cotangent. All done. Any question on that one? Okay, so what we've done up to this point, this would be like 12 different problems on the test so far. Okay, this was another 6 questions, and these would all be separate on the test. But I'm probably not going to ask you to take the same coordinate and use it 6 times. I'll probably give you one coordinate and say, do the sine. I'll give you a different coordinate and I'll say, do the tangent. And then I'll give you a different coordinate and we'll do something else. All right. Okay, questions on that? Okay. Let's try this one. Find the 6 trig functions of 90 degrees. Okay, you're still doing the same thing, but this is a little different. What's different about this problem than the first 2? Ethan?
They didn't give you a point.
They didn't give you a point. If they don't give you a point, remember, that's the first thing you have to figure out. Locate the point. Okay, that's great that they gave me 90, but I don't really want 90. I need the point for 90 because I need the x and the y to be able to plug them in. Where's 90 on that circle? Anyone remember the coordinate or even just describe where it is? Yep.
No, it's at 0, 1, and it's straight up.
Yeah, it's straight up right there. So now you have the x and you have the y. Now you can fill them in just like we did before. So we'll start with sine. Dylan, what's the sine of 90 degrees?
1/1.
What's the formula?
Oh, formula?
Yeah, yeah, just the y. And what's the y in this case?
1.
Just 1, yep. So you can put 1/1, but you can just put 1, that's fine. Devin, how about my cosine?
Will be x, which is 0.
Yep, it's x, which is 0. Good. Tyler, what's the formula for tangent?
Y over X.
Y over x. So a lot of times what I do, if I scroll down and I can't see the point anymore, just imagine putting a division sign right there. That's y, that's x. So just do y over x. Okay. What's 1 divided by 0? No, not 0.
1.
Not 1.
Undefined.
Undefined. You can't divide by 0 in math. That's like a very important thing. You can't divide by 0. Okay, so 1 divided by 0, we put exactly what Brian just said, undefined. All right. So now, let's take these, and Bridie, what do I do with all 3 of these to get the last 3?
You use the reciprocal.
Yep, so use the reciprocal, just flip them. Haley, what do you get if you flip 1?
-1.
So when you flip it, it doesn't change sign. It's just taking what's in the top and the bottom,
Okay.
and they just switch places the way they are.
So just be 1.
It would just be 1. All right. Tyler, how about my secant?
Would it just be 0?
Well, the cosine is already 0, so when you flip 0, it doesn't stay the same. There's only 2 numbers you can flip that stay the same, and that's 1 and -1.
Use that.
Yep, just let me sign your agenda. Think about this as a fraction. What would be in the bottom here?
Oh, it would just be 1.
Be a 1. So this is 0 over 1. What do you get if you flip 0 over 1?
You get 1.
Yep. Did you fill it out? Yeah. Tell me again, what do you get if you
1.
over 1?
0.
Yes, you get 1 over 0 when you flip it. And when you divide by 0, what happens?
Undefined.
Undefined. Right, that's undefined. All right. How about Caitlin? What do you think the cotangent of 90 is?
It would be x over y.
Okay. And in this case, what would that be?
Let me just Zero over 1.
Yep, it's 0, so it's just the tangent flipped. And if you take 0 and divide by 1, what do you get? 0. So when you flip 0, you get undefined. When you flip undefined, you get 0. So that's kind of like a special case. Great. So questions on that one? When you're dealing with a quadrantal angle, these are the types of answers you're always going to get. 1s, -1s, 0s, or undefined. You're not going to end up with any square roots like we had. That's only when you're dealing with an angle that's not a multiple of 90. All right, let's look at this one. Find, this time they only want 3 of them. The sine, the cosine, and the tangent of 3 pi. Hey, what's a little different about this one? Yeah?
It has a full revolution
Okay, and how are they giving me the angle?
in terms of pi,
In terms of pi, and that means that the units they're using are
radians.
radians. Okay, so they're using radians. I think it's going to be a lot easier if we do it in degrees. So that's our first step. Let's change the radians to degrees and do it that way. Okay, what do you multiply by to change radians to degrees? Yep, Ellie?
180 over pi.
180 over pi. So the pi's cancel out. And we're left with 3 times 180. How much is 3 times 180? Yep, 540. Okay, I like it better because it's in degrees now, but there's still something I don't like about it. And Jay kind of mentioned it. Yep.
You can subtract 360 from it?
Yeah, that's a big angle. That's too big for me to visualize where it is. Okay, so I'm going to subtract 360 from it. That's going to make it a little bit smaller and easier to work with. So 540 minus 360 is 180. Now that should be something you know the coordinate for. So you can draw a sketch, make your circle. Can someone remind me where 180 is? Yep, Allie?
It's all the way to the left, so the coordinate is -1, 0.
Yep, it's to the left. So we've got the x and the y. X is -1, y is 0. Now we finally have the coordinate. We can figure out what we got to figure out. All right, so Ryan, what's my sine here?
It's gonna be negative, no, it's gonna be 0.
Yep, so sine is 0. Sine is y, and y is 0. Yep. Justice, what's my cosine?
I don't know.
It's the x value. It's the x value.
Yep. What's my x value here? So if I look at my coordinate, what's the first number in the coordinate?
-1.
-1. And Kavani, my tangent, what's the formula for that?
Y over x.
Yep, and in this case, y over x is 0 divided by -1. And what's 0 divided by -1, Noah?
0.
0. So again, at this point, I'm not asking you to memorize anything right now. You can flip back in your notes to look up the formula. But that would mean you have to have the formula written down to do it, okay? So make sure you're doing whatever you need to so you know these formulas. Okay, so sine, cosine, and tangent. They did not ask for the other 3, so we don't have to do them. Questions on it? All right. All right, let's do this as our last one. 11 pi over 2. They want us to find all 6 straight functions. Jason, what do you think the first thing we should do with 11 pi over 2 is?
You should multiply by 180 over 5.
Why? What's that do?
Gives us an angle we can work with.
Well, why 180 over pi? What are you trying to do? I mean, I agree with you. I'm just wondering, what is that gonna? Why would I do that? What are you trying? What's your goal here?
I'm trying to get an angle, right?
Well, this is an angle too, right? 11 pi over 2. But it seems like you're trying to change it to do something. What are you trying to change it to?
Change it so I can get a fraction. Or
Okay.
You're trying to change it from radians to degrees.
We're trying to change from radians to degrees. That's why we're doing that. So multiply by 180, divide by pi. Pi's cancel. And let's reduce 2 into 180. What's 180 divided by 2? 90. Okay. And now we have 11 times 90, which is how much? You just think of 11 times 9.
Maybe 990.
990, yep. Okay, so we've accomplished our goal of changing it to degrees, but what do you think we want to do now? Tina? Yep, subtract 360 to bring that angle down to something smaller that's easier to visualize. So 990 minus 360, okay, I got 630. Now what?
Do it again.
Do it again. 270. Now we've got an angle that we should be able to get a coordinate for. And what's my coordinate for 270? Yep, Amanda. Ariana, sorry.
0, negative 1.
0, negative 1. I agree. And now let's write down our 6 trig functions using 0, negative 1. So John, what's my sine?
Your sine would be -1.
Good. Right, and Emma, my cosine?
0.
Perfect. Okay, Ethan, my tangent?
-1/0.
Yep, it's -1 divided by 0, which is undefined. Can't do it. Undefined means there is no answer to it. Brian, what about my cosecant?
-1.
Good, -1. Natalie, my secant? So which trig function do we have to flip to get the secant? So which trig function are you flipping? Because once you've got the 3 on the left, you don't want to go back and look at your coordinate anymore. You just want to take one of these and flip it. But which one do we flip to get this?
0.
Yep. And what do you get when you flip the cosine?
Undefined.
Perfect. You get undefined. Good, because it's 0 over 1. If you think of it as a fraction, when you flip it, that 0 goes to the bottom. All right, so we know when we flip 0, we get undefined. And Mia, if I flip undefined, well, I get 0. Yep, perfect. Good job. All right, any questions on that? Okay, so that's the first part of unit circle trig. Okay, so homework tonight is on page 116. It's 11 to 27 odd, and then 22 is the only even one I want you to try. You've got just about 15 minutes, so if you have a little time to start that. If you have any questions or you need to come talk to me, now would be a good time to do that as well. I have your test grade if you want to know that. Come talk to me.